Yeah, so we've got this remarkable record in the ice cores that shows us 100,000 year cycles in the climate. So it goes back about 1 million years, and we see these very regular but quite dramatic shifts from what we call glacials or cold periods or ice ages even, and then into warm periods we call interglacials. What drives this is initially changes in the Earth's orbit, and these are the Milankovitch cycles, and the 100,000 year cycle is a change in the shape of the Earth's orbit, from a circle to an egg. Every 100,000 years the Earth is slightly closer, further away from the Sun. And then we've also got this remarkable record of Earth's atmosphere trapped as gas. These are air bubbles. So snap frozen in time, air bubbles, samples of the Earth's atmosphere of its greenhouse gases. And if we look at the greenhouse gases, for example, we look at methane or we look at carbon dioxide, we see that the greenhouse gases also show the same pattern. So when carbon dioxide goes up, the temperature goes up, vice versa. When the carbon dioxide goes down, the temperature goes down. And for all intents and purposes, it looks like they're totally locked together in step. But in actual fact, if we look in detail at, say, one of these warming events where we're coming out of a glacial, we see a really interesting relationship. The first thing we see is the temperature increase. And it increases very slowly, but it increases before the greenhouse gases increase, so the temperature leads. And perhaps that's this weak effect of orbital forcing causing a minor warming. But it's enough to kick off a major change in the carbon cycle where carbon dioxide and methane suddenly start entering the atmosphere, possibly because the boreal wetlands degassed and the permafrost melted. That then starts pushing the temperature along. And without that, we wouldn't possibly get the dramatic warmings we see. They are amplified by the greenhouse gases, and we see that the greenhouse gases play this really crucial role in our climate system, particularly in taking us out of glacial periods and melting ice sheets. So it's sort of interesting when we look at the present day situation where we're seeing a dramatic increase in greenhouse gases, but you can forget about orbital forcing and natural processes. This is us. So instead of something natural kicking it off, we've kicked it off. So the greenhouse gases from the outset are in the driver's seat, and they're heading off, and temperature's struggling to catch up, but it will. We know that from all the models. We've seen some rise in temperature, with a lot more to come. We're the big perturber of the system this time. Humans are putting their imprint on the natural carbon cycle and driving it, perturbing it. We're the amplifier, and then it'll get amplified again by these greenhouse gases.